Hi everyone! Thank you for coming to our presentation. We're so looking forward to sharing our future materials with the Google and BDC teams. Meet our team. We are all current and former participants of the Masters of Industrial Design here at the Pratt Institute. Our proposal for you today is a drop-in solution for the Google Nest Mini. We are using living microorganisms and stored carbon to create a durable and fully home-compostable external hardware. Our material, which we are calling Biome, is a threefold composition of biochar, PHA, and a bacterial dye fabric. Let's start with our first component, biochar. What is this exciting material? Biochar is a carbon-rich, charcoal-like material that is produced by the heating of biomass in the absence of oxygen. This is a process called pyrolysis, which we'll get more into later. Biochar has been used for centuries throughout history by indigenous and farming communities to fertilize soils. What's more is that it's made from bio-waste feedstocks, can be produced at industrial scales, and it stably stores carbon for thousands of years, even in a landfill. How it's made. Bio-waste from agricultural and forestry industries is collected. This might be grass clippings, manure, wheat straw. This material is put into an anaerobic biodigester, where it is heated in the absence of oxygen. This process, called pyrolysis, results in biochar as the output. Now let's compare the carbon cycle versus the biochar cycle. In the carbon cycle, biomass is decomposed or burned, and 99% of carbon is released back into the atmosphere as carbon dioxide. In the biochar cycle, we intervene through the process of pyrolysis, where 50% of carbon from the biomass is stored in biochar stably. We chose to use biochar because if it ends up in a landfill, it still stably stores carbon there. We were specifically interested in it as a black plastic alternative because with infrared sorting, black plastics are currently falling through the cracks of our recycling infrastructure. For this reason, all those black plastics end up in a landfill or as a pollutant. Our material Biome is an incredible substitution for black synthetic plastics because rather than traveling straight from cradle to grave, it repurposes problematic waste and sequesters carbon. Our second component is PHA. PHAs are a class of biodegradable and biocompatible plastics made via a bacterial fermentation process, aka with live microorganisms. Let's take a closer look at what we mean by biodegradable. PHA is certifiably biodegradable by all 6 world standards. This separates PHA from PLA, which degrades only under industrial composting conditions and does not degrade in marine environments. PHA is made through a less energy-intensive process of fermentation that turns waste into a biodegradable thermopolymer that can be manufactured using the existing plastic infrastructure into these Google hardware products. PHA pellets can be molded with heat and pressure. We were able to form our PHA with the CNC machine and aluminum mold. These mechanical properties represent the average properties of PHA. In most cases, PHA is comparable with polypropylene. We used a multimeter and flame test to measure the flammability and conductivity of Biome, and we found that the combined material of biochar and PHA was neither conductive nor flammable. However, there are studies that demonstrate that graphene can be added to PHA to make a conductive plastic. We ultimately chose PHA because it repurposes waste through fermentation, creating living plastic that can easily and affordably be produced at an industrial scale. The microbes that produced our PHA were kept company by their bacterial cousins. We decided that our Nest Mini upper portion would be covered by a bacterial dyed fabric. By relying on the natural, non-toxic activity of bacteria to produce color, the Nest Mini can reduce its water consumption by up to 500%. While still producing easily reproducible textiles and mesh. To make bacterial dyes, sterilized textiles are inoculated and bacterial growth is encouraged. We chose bacterial dyes because we were inspired to facilitate the production of a product by microorganisms and bacteria. Our solution is Biome, a hardware casing made from stored carbon and microbes. Not only is it a beautiful, natural product that has the potential to offset manufacturing impacts, but it also can be produced using existing plastic production infrastructure. Here we have a sample of PHA pellets that we have injection molded with biochar. Biome has the potential to go a step beyond sustainable material and leverage the power of scale and Google's global impact through carbon sequestration. As industrial designers, we care deeply about the role that mass production can play in meaningfully combating the climate crisis. Our exploration of biochar has been featured in Dezeen, Forbes, and as a runner-up for the James Dyson Award. Our process begins with captured carbon and diverted waste. We suspend biochar in heated PHA and then mold the plastic into Google Nest products. This simple process we can manage and mitigate two of our most problematic waste streams: organic waste and petroleum-based plastics. Looking toward the future of Google hardware, fully compostable or partially compostable Biome products could be disposed of in any backyard. We've added natural substrates from ag waste to create a visual signal and indicate to consumers that the plastic they are holding is biological. These visual reminders create lovely colorways partnered with fabric dyed from different bacterial strains, ranging from ocean hues to earth tones. On to prototyping and user testing. Sadly, we cannot pass samples around to each of you in this virtual format, but instead we've asked a few of our classmates to describe the material differences between the Google Nest Mini and the Biome material replacement. We asked each participant to hold both hardware casings and describe the differences between them. Enjoy! We've created a material for Google products made by microbes for microbes. Biome is a resistant, carbon-storing thermoplastic. Due to the diversity of bacteria and source substrate, we're presenting 3 possible colorways for different user identities, all designed to fit naturally into a home environment. Part of our visual language will include a new Google graphic that uses colors representative of nature, growth, and decay. Looking at the product lifespan from cradle to cradle, Biome is a circular solution for hardware casing that seeks to mitigate the climate crisis through carbon capture and turning waste to treasure. Thank you for your time and consideration. Bye!